Hey everybody, Jeffrey Powers here, and welcome to another Build Day TV. I'm here with Alastair as always, and we are talking about AWS networking VPC costs. So it costs to use a VPC, Alastair?
Well, you'd think from the previous 8 episodes that there was no cost because I didn't once mention the costs of using a VPC. And, that would be nice if there were no costs.
Oh, absolutely. I love free, but sometimes to make money you got to spend a little bit of money, and that's what it happens here. But the best part is, with a lot of these costs, if you're not using it and you shut it down properly, the costs go away, and then you bring it back up, and everything is good from there.
So that's the pay only for what you use principle that is central to cloud, right?
Absolutely.
Pay for what you use.
Absolutely.
But then there is a flip side that goes really quietly and says you're going to pay for everything you use. So at the front it says you only pay for what you use.
Yeah.
But the wonderful thing is that you get a bill every month for what you used. The terrible thing is that every month you get a bill for what you used. So it is important as you're designing your architecture to think about cost, because that bill will turn up every single month. Mm-hmm. And it can be surprising. People can very easily end up missing one of the costs in their infrastructure and get this huge surprise.
Yeah, absolutely. Absolutely. And we've heard many stories about that. You can just do quick searches and find people that have basically hurt their startup immensely because of the fact that they've let things run.
Yeah. And as you say, when it's something that you're paying per hour, shutting it down when you're not using it is absolutely crucial. Mm-hmm. So let's start by thinking about our VPC and just hit the things that don't cost you anything on a VPC, because there are quite a lot of things that you're not charged for. So if you just create an empty VPC, there's no charge for the VPC.
Okay.
There's no charge for adding subnets to that VPC. There's no charge for having route tables attached to those subnets on that VPC. There's no charge for a network access control list. There's no charge for data transfer to and from an S3 bucket in the same region as your VPC.
Okay.
Yeah, so that one's a little bit of a surprise, right?
Yeah,
I can access a resource for no cost.
Yeah, anytime that there's an interaction, there'd be a cost to that interaction. So even though it's free to set up the VPC, I thought that there would be at least a cost for connecting up to create the VPC.
There's not even any hourly charge for having an internet gateway or a virtual private gateway. So there's no hourly charge for those either.
Okay.
Now we're starting to get some implications of things that might be chargeable. So let's start talking about the things that are not free. And I'm just doing some really gross approximations. Don't rely on the numbers that I put in here for setting up your budget. Go and actually find out the cost. But I took some pricing from the Ohio region this week, mid-2020.
Absolutely. If you're setting up your VPC, you should probably contact AWS and talk with a representative to make sure that you're doing everything in the right fashion and you're not going to get charged for whatever you're doing there. So we're just giving you a guideline to go from. So let's continue on with this.
Yeah, and really, it's in this section, it's more important to think about the relative costs than the absolute costs. But as Jeff says, AWS solution architects are there to help you with this. Also, AWS has some online costing tools. So I always used to use the simple monthly calculator, and some of these numbers are out of the simple monthly calculator. Just have a quick Google for that, and you'll find it. And there's a newer cost estimator that I've not gotten to learn. So the first thing is, something that can be a really big surprise is every time we deploy a NAT gateway into our VPC, we're going to be charged per hour for that NAT gateway to run.
Okay.
And we're going to be charged for every gigabyte of data that goes through that NAT gateway, irrespective of where it's going. And that works out to be around $45 a terabyte of data transferred.
That's technically not too bad at this point, and if you're hitting a terabyte, but you definitely don't want to see that bill.
So that's the thing, is a lot of this is just being aware of cost and relative costs and deciding architecture based on value.
Yeah.
Spending money is great when it's going to generate value and revenue. Spending money that doesn't generate value and revenue, or unnecessarily spending money, is the concern.
Yeah.
So the next thing to consider is egress to the internet. So traffic leaving your VPC going to the internet. I didn't mention on the previous slide that traffic coming in from the internet to your VPC is free, but traffic going out costs, and it costs $90 a terabyte, according to my little calculation. Incidentally, I use terabytes here rather than gigabytes so that it's actually a number that feels like it's important. When you see that it's about 9 cents per gigabyte, it's easy to think that that's not going to be important. But over weeks and months, the amounts can add up. The other thing to be aware of is that NAT gateway. If the traffic from the NAT gateway is going out to the internet, so I've got a private subnet with an EC2 instance on it that is sending data out to the internet, it'll go out through the NAT gateway at $45 a terabyte, $46 a terabyte, and then it will go out through the internet gateway at $90 a terabyte for an aggregate of $136 a terabyte for that transfer. So this is where the NAT gateway can be quite expensive because it's a 50% increase to your egress costs. Compare that with the direct connect egress cost. Only $21 a terabyte, and doesn't require a NAT gateway. So we're never going to get up to that 136 comparison, right? Direct connect egress costs are much lower than internet egress costs per terabyte.
Do you have a price for that between the two or no?
So for the fixed cost?
Yeah.
Direct connect has a fixed monthly cost, and the internet traffic doesn't have a fixed monthly cost. And so direct connect is $21 a terabyte roughly, and internet egress is $90 a terabyte. And you can see there's quite a difference. Yeah. I'll come on to another slide that's a comparison of the AWS part of the cost as well.
Okay.
Next thing that's going to cost on your VPC is intra-region transfer. So transfer within a single region, where it is from one VPC to another, or where it's from one AWS account to another. That S3 that is free within the region, it's only within the same AWS account. So if you are doing a data transfer to somebody else's AWS account S3 bucket, it's going to cost you $10 a terabyte to do that, even if it's in the same region. We'll see that the same charge is there for VPC peering within a region. And then there's a charge for region-to-region transfer. So if I have a VPC here close to me in Sydney, and there's another VPC for the organization that's close to where Jeffrey is, I'm trying to think where would be close to you. Ohio is not that terribly far away from you.
We can use Ohio, yeah, absolutely.
So for data transfer from Sydney to Ohio, I'm going to be paying around $20 a terabyte. That's potentially, again, a significant cost, particularly if I'm replicating a lot of data that's being generated in one location to another.
Yeah, it does, but then you think about it, it's not like a long distance charge as opposed to a local charge. So that's the only saving part of that.
Yeah, the expensive cost in here still seems to be that internet egress and NAT gateway. Everything else seems to be fairly moderate, and it stays fairly moderate. When we look at VPC peering, it's again $10 per terabyte. The real note on VPC peering is that a terabyte of data leaving one VPC will be charged against that VPC at $10, but the VPC that's receiving the data is also going to be charged $10 for receiving that terabyte of data.
Okay.
So there's what feels a bit like double dipping going on in that transfer.
Yeah.
So as we frame this out and say, well, access to egress to the internet is the most expensive thing, and NAT gateway transfer is fairly expensive too, but all of the other ones are smaller costs. When they're staying on the AWS network or private networks, they are relatively small costs. So we start thinking about NAT gateway as our cost. The published number for Ohio is 4.5 cents per hour to run a NAT gateway. That ends up being $32 a month per NAT gateway. And for high availability, we have one in each of the availability zones we work with. That usually means that for a normal production-ready VPC, 3 availability zones, 3 NAT gateways, around $100 a month for those 3 NAT gateways before they've transferred any data. Again, it's not a huge amount of cost, but it's when we start moving multiple terabytes of data through those NAT gateways that it starts to cost us a little bit.
Yeah.
So how about if we consider not using NAT gateways? We use the NAT gateway because we have a private subnet that's configured with no direct route to the internet. It goes via the NAT gateway instead. How about if we took that private subnet and allowed it direct connectivity to the internet? That means we don't have the NAT gateway charge, we just have the internet egress charge. But we wanted a private subnet to protect it from the internet, protect it from hazardous things coming in. Well, what if we do that by just having these subnets that don't have a public IP address? And so you can't have direct inbound access. We're allowing direct outbound access, but not any inbound access. Having the ability to have all of our subnets public, rather than having a separation of public and private, and then have the inbound access only into some subnets that allow public IP addresses and DNS names, and no public IP addresses on the other subnets, means we don't need any NAT gateway.
Okay.
The risk is when you provision a new EC2 instance into that back-end network, you can choose to override the subnet settings and say, give this particular EC2 instance an IP address on the internet, a public IP address. Now all of a sudden we've got a subnet that we didn't want any internet access inbound, that because we made an administrative error or we just haven't followed our instructions correctly, now we've got a subnet that is allowing direct access from the internet. So there's better isolation if we have private and public subnets, but there's a lot more cost for that isolation.
Okay.
And as always, it's really about what's the value? What's the regulatory compliance regime? What's the security regime? And is it worth the extra spend?
And there's no security change.
So security groups still work exactly the way they have previously. So we can set a rule that says on this particular EC2 instance, restrict where you're allowed to connect in. And irrespective of whether there's a public IP address or not, if you've restricted to say only allow incoming connections from within the VPC, well, the connection from the internet won't get in. But of course, if we're making the mistake of putting a public IP address on an EC2 instance, maybe we're going to make a mistake with a security group as well.
Good point. Good
So
point. Yeah.
you've got to be thinking about where you're implementing your policy.
Yeah. So is it best to have somebody else kind of checking your work, so to speak?
As a general principle, yes. Peer reviewing of particularly significant changes is really important. Most enterprise organizations with a change management process will require that peer review.
Okay.
So as we rock on through, how am I going to go about minimizing the amount of data I transfer through my NAT instance? So if I'm retaining a NAT instance, one of the ways I can do is have the EC2 instances on the private subnet cache data. And so the less times they have to re-access the same data through the NAT gateway, the less data that transfers. So one of our options is to cache inside the EC2 instance that's requesting data. Another option is to put a caching proxy in. So put something like Squid in as a cacher for anything that's downloaded. This can be extremely useful if you're doing things like updating guest operating systems from internet sources.
What's a Squid?
Squid is an open source web proxy server.
Okay.
It allows you to then have an EC2 instance inside your NAT gateway, so probably on a private subnet, that provides a cache and speeds up access to data, but also means that it's downloading less data from the internet. Another thing to think about is if a significant part of your data that's required inside your VPC, inside the private subnets, is about software distribution. Now, it might be that you have a whole farm of Linux instances that you run for a long period of time and that you need to apply updates to. You may choose to put a software distribution server inside your VPC, so that software distribution server does one download of the packages and then distributes on to all of your servers, rather than each of those Linux instances going out to the internet for its data. These are all three of these are about caching data inside your VPC to minimize the amount that goes through the NAT gateway.
All right.
Another thing, one of the processes that we often have is managing the things that are in our private subnets using a jump host that's somewhere in the environment, or allowing some kind of connectivity that goes through management from the internet. Well, if we use Direct Connect, if we have Direct Connect, we have a private channel connection through, and that's a lower cost than any of our internet egress or our NAT traversal. So using our Direct Connect as the lowest cost way of transferring data out of our VPC. And that also applies to software updates. We could do our software distribution from an on-premises repository for maybe our Linux updates or our application updates that are being accessed frequently. Data transfer across Direct Connect doesn't have any NAT charge and doesn't have any internet egress charge. Starting to see Direct Connect as being a really effective way of reducing our data transfer costs.
Yeah.
But of course, we can just make all of our subnets public to avoid NAT at all. And this kind of works, the architectural changes this. We've seen this design before as we were looking at the routing, having a private subnet where the default route goes to a NAT gateway and a public subnet where the default route goes to the internet gateway. Well, we switched to a method where both subnets have their default route going to the internet gateway. And the way we control inbound access is by whether the public IP address is assigned. So you can see that the public subnet, Pizza Public 1, still has public IP addresses, which means you can get into that subnet, whereas Pizza Private doesn't have a public IP address, so there's no way to get traffic into it. You can still directly access the internet from that public subnet, from the private subnet. AWS would actually define it as a public subnet because it has a route to an internet gateway, but we're still treating it like private because we haven't given it an IP address. But that's the scenario where if I had an EC2 instance attached to Pizza Private 1 subnet, when I deploy the instance, I can say I'd like a public IP address, please. Okay. And that may not be compliant with your security policy. You've got to be much more careful about how you implement your security policy with this model.
Did you calculate the prices with NAT or no NAT in this slide or no?
We're eliminating the $45 per terabyte transferred through the NAT gateway.
Okay.
That's the cost we're eliminating.
So that's the difference is $45
a month.
Yeah.
Yeah. Yeah. It's, if we've got 3 AZs in play rather than just the one that we've got here, that's $100 a month plus $45 a terabyte.
Okay.
So if we consider our on-premises connectivity too, because we have 2 ways we can get our private network into AWS. One is the VPN and the other is Direct Connect. VPN costs us a per hour charge, roughly $36 per month, plus data transfer charges at internet egress costs. So $90 a terabyte for data transferred from on-premises to from AWS to on-premises over a VPN. Whereas Direct Connect we know is only $24 a terabyte, but there's a much higher per month cost. The cost from AWS for a 1 gig link is $240. For a 10 gig link, $1,800. Now, I haven't covered the cost to get from that edge location where the Direct Connect goes back to your on-premises network, because that really depends on your relationship with your provider. But just that AWS cost, the 1 gig breaks even on the AWS cost at 3 terabytes per month of data transfer.
Yeah, yeah.
Like just over 1% utilization. The 10 gig link, it's only 27 terabytes of data transferred, and it gets up to the same break even on that AWS cost at 1.1% utilization. That's without considering that egress charge for your private subnet would have a NAT gateway charge that's adding 50% to its cost. So you can see that there will be quite a lot of potential for Direct Connect ending up costing you less than using a VPN or internet-based egress. I haven't even started to think about what if I use my Direct Connect in my on-premises internet connection rather than the AWS internet connection? Because that's a little bit further left field than even I'm considering at the moment.
Yeah.
As you are designing your VPC, you do need to consider particular things. Internet egress is not free. Getting out of your VPC, transferring data out to the internet, and that's the most expensive network transfer I've seen in there. NAT gateways, if you use them a lot, they get expensive. And Direct Connect can end up costing you less money, even though there is a higher per month cost, because there is a much lower per terabyte cost. VPC costs can end up being a really significant element.
Yeah.
The most important thing is to understand them before you start using the services and before that bill starts rolling in with a surprise in it.
And always consulting AWS architects out there, consulting with other people, making sure that you know what's going on and how it all works, how the cash flow comes through. That way you're not going to eat up your budget for the year just simply on testing products. Because I know you've actually told me that you left something running and it costs you a little bit because you have to pay for whenever you set up test environments.
Yeah. So I get a small budget for running training, but I get paid that in a quarterly chunk. And if I fail to turn things off, if I don't shut down what I stand up in a course demo, I can end up with a significant cost. I can burn through a 3-month budget in about 2.5 weeks if I forget to shut things down. And I have two things. I have alerts set in my AWS account. So I have budget alerts in the AWS account. But I also run, every Saturday morning, I run a PowerShell script on one of my local workstations to check that I haven't left some of those resources in place. And that PowerShell script emails me and says, hey, turn this stuff off or you're going to get a bill.
Yeah.
I like that kind of early notification.
Yeah, that was going to be my next question, is how can we make sure that we don't accidentally leave something on? So do you have any of those scripts that people can look at, or do you know where they can go?
I haven't published the stuff that I used notifying me that I've left the particular resources I'm inclined to leave behind. I haven't published anything about that. But if you Google AWS billing alerts, that's the bit that will set up a notification. You can set a threshold and say, you should email me if my AWS spend for this month is going to be X dollars. Now, for me, as a really small organization, that threshold is somewhere around $2 or $5.
Okay.
But if you're an enterprise organization, you may expect that this AWS account is routinely going to cost you $4,000 a month. And so you may set an alarm on it. If it's going to cost me $5,500 this month, notify me because something's gone wrong.
Okay. All right. Well, cool. Wow, that's a lot of cool, lot of great stuff, information right there, from how you start free to how you start paying through the nose if you don't have it all set up right. So amazing stuff right there. Thank you very much for sharing that with us, Alastair.
Absolutely a pleasure. And I think this is our last episode on the basics of AWS networking. If there are other areas of AWS that you'd like us to start looking at, please do comment up in the on YouTube, or let us know by email what other areas you'd like us to look through. We're going to have some stuff working with a bunch of vendors shortly, and so there's going to be a lot more cloud things. But this is the end of the AWS networking series.
Awesome. And yeah, definitely check the other 8 episodes, actually technically 16 out of the whole group of here. And of course, if you have any questions, when you subscribe, you can always ask questions down there. You can always contact Alastair. You can contact me. We'll try and answer them. And then we'll do a follow-up in about a few months, and just if there's any questions from there. So. All right, this has been episode 9, the final episode, AWS Networking VPC Costs. Once again, thanks a lot to Alastair, and my name is Jeffrey Powers. Until next time, we're going to have more content coming up, and just watch the channel. Go ahead and subscribe. We'll see you later. Take care.